Welcome to the Piping Engineering YouTube channel. In this video, we'll learn an easy method to calculate pipe lengths and elbow angles for a double rolling pipeline. Then we will this method to examples in a fabrication isometric drawing. Before we start the video, I want to give a big thank you to all our members and subscribers for their amazing support. If you want to support our educational mission, please consider purchasing one of the membership packages and subscribe, linked in the description below. Alright, let's dive into today's lesson and get started. In a double rolling pipelines, for calculate pipeline section we use three-dimensional positioning terms. The pipeline's eastward travel is known as the run. The pipeline's upward travel is called the set. And the pipeline's northward travel is referred to as the roll. These terms help accurately define the spatial positioning of the pipeline as it moves through different planes. In such cases, the following formula is used to calculate the pipe section length. Travel length equals under root square of the run plus square of the set plus square of the roll. This formula comes from the Pythagorean theorem in three dimensions, where the run, set, and roll represent the pipeline's movement along the eastward, upward, and northward directions, respectively. This method is applicable when the pipeline displacement forms a right-angle parallelogram, as shown in the video. Using this formula allows for precise calculation of the pipeline's travel length within the right-angle parallelogram setup. In this type of double rolling pipeline, isometric drawings typically provide the lengths of the run, set, and roll. These measurements help in calculating the overall travel length and determining the exact positioning of the pipeline within the three-dimensional space. Let's examine this method we learned on a fabrication isometric drawing. In this fabrication isometric drawing, the pipeline travels to eastwards. This pipeline first moves downward by 359 millimeters, then continues eastward for 617 millimeters, and finally shifts northward by 67 millimeters. And finally continues eastward again. As you can see in this fabrication isometric drawing, the pipeline displacement forms a right-angle parallelogram as shown in the video. To verify the accuracy of this pipe section length, we'll use the method we learned to calculate it. To calculate the length of a pipeline that moves in three dimensions, eastward, upward, and northward, we can use the Pythagorean theorem in 3D. Let's mark via L length of the pipe section. L equals under root 359 squared plus 617 squared plus 67 squared. Let's go these calculations step by using scientific calculator. 359 squared equals 128,881. 617 squared equals 380,689. 67 squared equals 4,489. Now add these results into our formula. L equals under root 128,881 plus 386,89 plus 4,489 equals under root. We are using calculator and find that 128,881 plus 386,89 plus 4,489 will be equals 514,059. So, in our formula, pipe section travel length L will be equals under root 514,059. At last, again using calculator and find that under root 514,059 will be equals approximately 717. Thus, the length of this pipe section as depicted in the piping isometric drawing is correct. Now, let's calculate the accuracy of the elbow's degree, which is shown as 30 degrees in the isometric drawing. The degree of the elbow will be determined based on the right triangle formed by these dashed lines. To calculate the degree of the below elbow, we will use this formula. X degree will be equals r cosinus, adjacent divided by hypotenuse. In the right triangle formed by these dashed lines, the adjacent side is shown as 621 millimeters, and the hypotenuse is shown as 717 millimeters. We substitute the dimensions from the isometric drawing into the formula and proceed with the calculation. The angle x will be equal to the arc cosine of 621 divided by 717. Using scientific calculator and found that arccosinus 621 divided by 717 will equal approximately 30 degrees. So, in this production isometric drawing, the 30-degree elbow size is correct. We applied the method learned earlier in the video to the fabrication work drawings and verified the accuracy of this method. By using this method, you can easily calculate the lengths and angles of pipe sections for your desired pipelines. This educational video is coming to an end. If you enjoyed this video, don't forget to subscribe so you won't miss out on future content. Feel free to share your thoughts in the comments section below. I'd love to hear from you. By becoming a channel member, you'll be supporting our work and gaining access to exclusive perks. A big thank you in advance to everyone who leaves a comment or a like. It truly makes a difference. Thank you for watching, and I'll see you in the next video. Take care.